Hello and welcome to RapidDirect channel. I'm Betty, a sales engineer here at RapidDirect. My role involves assisting engineers, designers in bringing their innovations into reality and ensuring they get the best result from RapidDirect. Case-by-case study might be the most attractive series that every product developer and mechanical engineer is interested. Today, our spotlight is on this automotive part, the mainbar. This one is crafted specifically for Formula student team. It's made of aluminum and serves as the base plate for the paintballs. The mainbar plays a vital role in ensuring a well-functioning brake system and suspension for the race car. Well, how do you get these parts machined? Let's break down in detail. So to take a closer look at the structure of these components. As you can see, the mainbar is asymmetrical. It features different structures on the left and right sides, requiring careful machining from multiple directions. There are a total of 7 directions that need to be machined. So, a 5-axis CNC machine is required for this task. In addition, the parts have thin walls and numerous cavities, which require careful clamping. We break down the machining process into several steps, starting with roughing. We mill the mainbar from a solid aluminum block, adjusting 6 directions from the front surface. After completing this, we proceed with roughing the back surface. Following the rough milling, the part undergoes heat treatment to release stress. The final stage involves fire milling, which follows a similar process to rough milling. First, the bottom surface is clamped for fire milling of the front face. Then, the front face is clamped for fire milling of the bottom face. Now, let's take a deeper dive into the challenge of machining this part. Challenge 1. Complex structure. Standard 3-axis CNC machines can't handle this complex task. A 5-axis CNC machine is required. Challenge 2. Thin wall. Single machining is a big challenge, as easily bends and vibration during milling. To solve it, we applied high-speed machining with faster spindle speed and low-feed rates, which helps control heat and enhances the surface finish. Additionally, we used a careful clamping method, ensuring secure yet balanced placements to prevent warping during machining. Challenge 3. Holes with tolerance. Machining holes with a plus and minus 0.05 mm tolerance is another challenge. Tool deflation, especially in deep holes, often lead to deviations from intended dimensions, while heat from friction causes thermal expansion, further imparting accuracy. These challenges resulted in increased machining time, taking approximately 50 hours to complete, thus increasing cost accordingly. That's all for today's mainbar case study video. If you enjoyed this case study breakdown, don't forget to like and subscribe to RapidDirect channel. And remember, our professional engineering team offers free DFM support to save your time and money, ensuring you get the best results. Bye!